Hello, this is Freethought Forum, a program by the Atheist Society of Knoxville and the Rationalists of East Tennessee. I'm Faithless Forrest.
And I'm Naturalist Nathan.
Naturalist Nathan.
And I'm David.
And we want you to know that if you don't believe in God, you're not alone. Right here in East Tennessee, you can find free-thinking atheists and agnostics. This is a show for them and for people rooted in a life of science and unfettered by supernatural beliefs.
Today's, we will further discuss and evidence ideas about the origin of life.
Mm-hmm. And before we begin, we want to tell you, our viewers about the sponsors, the Atheist Society of Knoxville and the Rationalists of East Tennessee.
Alrighty, the Atheist Society of Knoxville, or ASK, frequently has a fun meetup at a bar or eatery. The next meetup is Tuesday, 5:30 p.m. at the sort of new location, Black Horse Pub and Brewery. That's at 4429 Kingston Pike in the Western Plaza Shopping Center. For details, go to knoxvilleatheist.org. And when you get to the meetup, look for the silver-jacketed copy of The God Delusion. We have a slide with that picture standing upright on the table.
Yeah.
And as Matt Dillahunty at Atheist Experience says, everyone is welcome to our happy hour for food, drink, and conversation. But if you plan to preach, proselytize, provoke, or punch, please don't.
All right. The Rationalists of East Tennessee have several regular monthly meetings. See our website at rationalists.org for details. The first and third Sunday mornings of the month are usually lectures with lively roundtable discussions. The second Sunday, we hold Skeptics Book Club. On the fourth Sunday, we are mixing it up, sometimes with a potluck get-together in a member's home, which we call a reflections meeting.
Yeah, and later in the show, we're going to be given some websites with additional information like time and locations.
I didn't work up anything in the news. Did either of you bring anything topical in the news that you want to talk about or gripe about?
Not me. I mean, the only news I hear about is really political. So.
Alrighty. Yeah, well, the politicians are always passing laws based upon their imaginary sky friend, and that gives us things to sometimes talk about.
True.
Nathan, got anything? Alrighty.
Not right now.
Why don't we jump into the program? Last week we were speaking about the Drake equation. Mm-hmm. We may have left a few things unfinished about that. I don't think we ever actually came up with a possible number.
Right. I think we got to touch on all the conditions. Maybe the math, we could do later. They could do at home.
I was going to make a hand-waving argument that works like this.
Okay.
Our galaxy has approximately 300 billion stars.
Okay.
And I think one of the terms in the Drake equation that had become much more well known since Drake first proposed it is about how many planets are there around a star.
Right.
And I think his original numbers was to say, well, let's assume it's about 1 in 10. Well, we now know that it's much more likely to be greater than 1. And they're waving a thing at us. We have our first call. Nathan, push the on-air button and greet the caller.
Hello, caller. May we have your name or nickname?
It's Charles from Central Illinois.
Hello, Charles. Thank you for calling. We're talking about abiogenesis here. And did you have a comment or a question?
Well, something that might also relate to both abiogenesis and last week's show.
Uh-huh.
Is that apparently they think that there's an unusual asteroid in an unusual orbit near Jupiter.
Right, I've heard about that one.
And so they're thinking it's maybe an extra solar, it's outside our solar system?
Yeah.
Yes. What I'm thinking of is that when they examine some of the large interstellar clouds that they see with the telescopes, they've noted that a large percentage of them have complex chemical compounds, including some that are organic. Now let's define that term. Organic means one that has carbon as a center because of its chemical properties, allows it to hook up to long chains with other chemical elements. So abiogenesis may well be the result of natural occurring phenomena that from other sources dumping chemical compounds onto the proper conditions.
And those are things we were planning on trying to talk in some more detail today. David, you're some kind of a biologist, right? Do you want to give your credentials?
You know, maybe one day. Right now, I'm just in study, but
You're going to school studying?
right, biology. But I do hope to pursue in the field of exobiology. So maybe one day I might give NASA a call and try to see if they've got some spots available. But like I feel like I've maybe discussed that previously, but
Well, we can assume that there is at least one new viewer out there today.
right. So at least in regard to that, I mean, the conditions that you're going to be looking for, like we're going to be talking about today, I mean, they're not just here. Like you were saying, you can, with these extrasolar meteorites, asteroids, I mean, that's places we might look and say, you know, oh, we can find these kind of molecules in other places besides here. So we're not really that special. I mean, it could be happening outside of our solar system.
There's from what I understand, there's a whole new field called astrobiology, and it is exactly what you're talking about, detecting organic chemicals outside our solar system.
So, Charles and I got a little more, we've been around the sun a few more times. Our atoms have been around the sun the same amount of times your atoms have, but in the configuration that's my body and Charles's body. I first read some things from Isaac Asimov where he was talking about and I think this would have been in the 60s, the known existence, I think due to spectroscopic signatures, of organic molecules in interstellar space and or around or associated with molecular clouds in our own galaxy. Charles, what have you read? Were you like me, you an Asimov fan?
Yes, and as I recall, he was talking about that and how he also noted that several of these chemical compounds that are different from ours are that are all organic but have different configurations with different elements than ours, may well be the formation for some forms of life. And the concept of abiogenesis, one of the things that is necessary is to have an energy source. For instance, down in the depths of the ocean, they discovered the volcanic vents where life is flowing around in incredible numbers, but they're living in temperatures and pressures that would kill us in like under a fifth of a second. So there are some chemical processes that don't need, say, sunlight, but do require a source of energy. And that energy is made up from different chemical compounds in these volcanic vents that are used by these life forms to survive. Another factor is life doesn't have to have the supremely complicated structures that our cells have. One of the great fallacies against scientific idea of abiogenesis is how it would take to create a cell as it exists today. When abiogenesis is talking about how chemical compounds would form some kind of cell or something like that, just about, 3 billion years ago, which would be much, much simpler than what we have today.
Right.
Charles, I think you're talking about things. There's claims by intelligent design proponents. I think his name is Dempsey. His first name won't come to me now.
Well, he's just one.
Yeah, but Dempsey, talks about the odds of this molecule forming something like that, and he, spouts off this huge number.
Spontaneously.
Yeah, but the thing is that he's never proven, so to speak, that molecule is essential to form life. In other words, he's working on a problem that's irrelevant.
It's a straw man.
Right.
Yeah, and but he gets mileage out of that. He writes books and sells books, and you got to sometimes wonder if he's just not honest enough to want. If he wrote what was honest, he couldn't sell a book. In other words, is he actually victimizing his own audience? And if he was here,
victimizing, or is he like the guy that stated that if the Bible said 2 + 2 = 5, I would change my worldview to match it. So that he's kind of like, as Aaron Raw once said, these people act like they were addicted to the concept and can't get rid of it.
Yeah. Well, I've watched. I think his name is William Dempsey on a few YouTubes.
Oh God, no!
And he. Now, Charles, which god were you appealing to? Come on, was that Zeus? Please be specific. The flying spaghetti
god
monster?
Probably the invisible pink uniform.
Ah, the IPU. All right, we've never done a whole show devoted to the IPU. Perhaps in the future.
Or the flying spaghetti monster.
The flying spaghetti, his holy noodliness has been featured on some of our shows more thoroughly. But Charles, we got some more things here. Well, let's thank you for getting us started. And I tell you what, let us work on our material. And if you see some gaps in our theory, call us back later in the show. We want to let some other callers have a shot at us as well. Okay?
No problem.
All righty. Thank you.
Okay.
Bye.
Push the off button. All right. So, we've used this term abiogenesis, but it's one often that the creationists don't even know about, because they'll talk about whenever we do a show about evolution, they'll call up and say you can't explain the beginning of life, and evolution can't explain the beginning of life. And they don't realize that, well, in science we divide these problems down, and there's a word for it, and it's for the beginning of life, and that is not evolution.
Right.
So we got something here from Wikipedia. Maybe we can get Nathan to help us with the Wikipedia on that.
Oh, sure. Well, it starts out with abiogenesis, or informally the origin of life, is the natural process by which life arises from non-living matter, such as simple organic compounds. The transition from non-living to living entities was not a single event, but a gradual process of increasing complexity.
So, I've had many times when I've had on a Facebook exchange or at lectures that we went to where creationists are speaking, where they'll talk about how the second law of thermodynamics prevents life from forming because everything breaks down according to the second law of thermodynamics. And
Right.
Have you encountered this argument?
Yeah, and it's the misunderstanding of what that entails. So, like, with continuous energy input to the system, it doesn't break the second law.
Well, in fact, they can't even say what the second law is. They will say something like, well, disorder increases. And in fact, if you go to the Wikipedia page on entropy, that quote comes from one of the early pioneers in it, but they'll say that this is, it is, oh goodness, there's a term when to describe how when a term should no longer be used. It's I'm trying to say it's disapproved for new.
Obsolescent?
It is an obsolete term. It's disappreciated. There we go. It's disappreciated because it's so vague. In it was an assumption that you have a closed system with no energy input. So since it's not clearly stated, people think they can apply that, and it doesn't work.
Well, one of the things that I think is interesting about energy in a system is that we're not even sure what energy is, right?
In a certain sense, we can actually be very certain, and that is that it is a thing that we calculate, that after the universe goes through various transformations, when we do the calculation again, we get the same number. But it's not like Richard Feynman did a nice lecture where he talked about the analogy of little children's blocks, and that you could stack up and rearrange in different configurations, but that no matter how you stack them and rearrange them, the blocks don't disappear or spontaneously come into existence. And in that sense, and he says the laws of energy are like that, except the first thing you got to get over is that there are no blocks. There are no little indivisible chunks of energy. People get confused when they hear about quantized energy and think that, yeah, there is some fundamental atom of energy, so to speak, that can't be divided. But that's not true. You can have, so far as we know, arbitrarily small amounts of energy. But when you sum up all of the energy in a closed system, it doesn't change. So maybe that was I'm a physicist, so I got long-winded on that. Let's actually not try to get into physics here. What we really want to do is talk about things that are more chemistry related, because there are interesting things on that. In fact, we've got pages worth of interesting things. I think, Nathan, some of this was what you wanted to share?
Yeah, that's right. And let's see, something you said briefly though about what you taught in physics and breaking the first and second laws of physics, where people think, things only get less complicated, and then generalize that into, well, you can't have more complex things emerge.
Yeah, so what they say is, well, things always break down, but yet when they also talk about the second law, they say, well, disorder is increasing. Well, in a sense, they've actually stated in mutually exclusive ways, because when chemistry happens that releases energy, you may get a bigger molecule. That bigger molecule, in a sense, is more ordered than a bunch of independent molecules that went into it. So order increased.
Yeah.
Yeah, and what I find, so it's order, and it's also information.
Okay, anyway, I hadn't expected you to bring up information. But behind us now we have a slide. And so what is this?
Oh, this is an example of emergence, where things do become more structured with time. And it's a trend that happens all the time in almost any scale and timeline and environment we look at. As long as there are small pieces that can interact and then form more advanced structures.
So the snowflake is actually an example I've used where people say, well, left to itself, nature becomes disordered. And I will say, well, imagine a cloud. Mm-hmm. Cloud is water vapor dissolved in the air, and clouds can form snow, ice crystals. And then I say, is an ice crystal more ordered? And of course they have to say yes. And so I say, well, that sounds like the second law of thermodynamics is broken all the time if you say that you can't get order out of disorder, because snowflakes do it all the time. So what's more likely, that the second law of thermodynamics is violated all the time and therefore shouldn't even be called a law, or you're misapplying it? And so that's been a useful conversation I've had with people, because they'll say, well, I guess I don't know what this means then. So how can snowflakes form if entropy, disorder, is always increasing? It would seem that snowflakes could never form, but yet they do.
Right, and of course the shape is based off of the moisture content and the air pressure. So that I always thought that was interesting. It makes me think of the as we're looking at it, how they look so different. The whole no two snowflakes look the same. I mean, it turns out that's actually not true. If you put them in identical conditions, they'll form the same shape, which is interesting.
In fact, sometimes, often happens right in the fall when you get some of those first early snows, there'll be these huge flakes. And when you look at them as they're falling, you say, well, they're similar in size and a similar degree of fluffiness. Mm-hmm. So even on a very large scale, you can say, yeah, there is some similarity. Now, if someone says no two snowflakes are identical, well, okay, the word identical is very strong, and I can't say that, there's the identical number of atoms in each one.
Right, the exact structure of it.
But, well, there's a flake, a picture there right between your head and Nathan's head that has a strong filled-in hexagonal structure. Mm-hmm. Those kind of flakes, if they are real long in the axis that's perpendicular to our screen, they're like a pencil. Pencils are hexagonal, I think, or are they octagonal? I think they're hexagonal. Yeah. And those kind of crystals can form and get suspended by air currents and produce refraction patterns that create some optical effects that we've heard of. How many people have heard of a sundog? A sundog is a little rainbow that you see on either side of the sun, usually in winter-like conditions, because it takes ice crystals. And then there's another phenomena called a sun pillar or a sun column, and this will be something that will be above or below the sun, and in fact can happen when the sun's below the horizon. You'll get this pillar that's over where the sun is about to rise. And once again, that's a phenomenon that happens often fall or spring, and they're very striking when you see them, and it'll make people think it's like some action of a deity, because they're I'm going to say they're just beautiful.
But those are less common. I guess the most common example of something like that would be rainbows.
But rainbows happen from an entirely different thing. Those are spherical drops of water. Right. The sun column and the sun dogs come from the hexagonal structure, and it will be a massive number, a whole cloud full of crystals that are approximately the same size and therefore have the same optical property through them. If they were all a random collection of hexagonal crystals, none of which are the same, you wouldn't get the reinforced behavior that gives you the sundog and the sun column to the same degree.
It is an emergent phenomenon.
Yeah.
So also rainbows, because you have tiny little droplets that are just little round droplets, and they make tiny little rainbow where different colors go out at different angles in a circle, and then from one person's perspective, they see the rainbow, right? Mm-hmm. And then that is a much bigger structure. It's a structured organization of the light because of very small, similar things that interact with something.
Rainbows are funny things because, of course, there is nothing at the place where a rainbow appears to be. So that maybe that's a higher level of emergent phenomena. So, but the point about the snowflakes is that when someone says the second law of thermodynamics says that life can't start spontaneously because that's the creation of order out of disorder, you simply have to look at a snowflake and say it happens all the time. That you can and so using the word order is not helpful in the conversation. There's something else going on. Now, obviously, we don't get new life forming all the time, not the same way we get snowflakes forming all the time. So it's not as trivial as that.
Right. But of course, that goes back to the changing conditions we find ourselves in. It's like the times where we would have the creation of life, we wouldn't have the creation of snowflakes, for example. So like this sort of conditional basis of like when things can happen. That's one thing I hear sometimes too. It's like if life spontaneously arose from these chemical processes, why isn't it still happening today? Well,
so let's, I think we've got a slide here about in the lab. I think that's the subject for that slide. And look, there it is. So a little bit before I was born, in the early 50s, I'm born in the late 50s, Miller and Urey did this experiment. They actually conducted an experiment that people had speculated about for a long time. And in fact, Darwin himself, I don't think it was in Origin of Species, maybe it was, he was clear that he was talking about how do species come into existence, and that is from other species. And in the very last paragraph of Origin of Species, he said, by the process of random variation and natural selection, many species have been and are coming into existence while the Earth has rotated around the sun so many times. And that this is a grander view than it was just some magic act.
right.
And he said then that all of the creatures alive today may stem from one or some first few creatures into which life was first breathed. And his choice of the word breath is interesting because breathing is part of the process of getting the chemicals that allow for the release of energy that is essential to sustaining life, because life is a non-equilibrium position with or situation with the environment. We have to keep breathing if we're to keep living. So, have either of you heard about the Miller-Urey experiment previously?
Yeah. I mean, so
Describe it to me for our viewers.
Oh, okay. So what they've done is they've taken gases that at the time were believed would be in Earth's early environment. So you've got ammonia, methane, and let's say
water.
Water, yeah, right. And then you've got they have electrodes that stimulate activity that would have been happening on the surface. I mean, it's still happening today. If you've
And they
never
were
seen
simulating what? There's a word we want to hunt for.
like specifically like lightning strikes.
There we go.
Right. I mean,
Lightning.
I'm sure everyone has seen lightning at some point. So this is something that's always been happening. So this is always, the electrodes in there. I don't want people to be thinking, that's in a sense cheating. That's not replicating early Earth, because it really is. So when they do this and have this sort of a liquid that they have a burner to cause evaporation, and they've got a little condenser. I think you can actually see in between your heads there where cooling.
There's a little flame underneath one of those flasks.
Right, and that's where you're getting condensation again. So they ran this. I forget how long they ran this for.
Within a few days, they started to see some color change, and they may have run it like the equivalent of like 3 weeks or so.
Right. Okay.
So the point is, it happened fast.
Right. Much faster than you would, like, say you've got a billion years. I mean, the first signs of life, we see it, if we go by certain research, 4.1.
So the importance of saying that it happened fast is to say that these simple chemicals of just methane gas and just ammonia gas, those are non-equilibrium situations. The more equilibrium situation is to combine into things that look more like organic molecules.
Right.
So what kind of organic molecules did they find?
Well, they ended up making amino acids. So,
And there's at least one viewer out there who maybe doesn't know what an amino acid is.
right. So with amino acids, that's really the building blocks of proteins, and proteins are the things that do everything in your body.
So proteins are the things that make up muscles and tissues, things that basically aren't fats. They're going to be proteins in a living creature.
Right, and it carries out a lot of the function in the cell, like the channels that let things in and out of the cells, the surface markers.
The chemicals that actually control and guide the release of energy, the burning of food, so to speak, have enzymatic or catalytic properties, and those are proteins. And in our bodies, there's, I think, a number I saw quoted that there are 20 amino acids that are found in all of life. There are actually more kinds of amino acids than that, but all of life is built using a palette that's only as small as 20. And when they did this experiment, after a week or so, they found, I think there's something here in the notes here. I think they're going to say they initially reported they found like 10 of the 20 amino acids. They also found amino acids that don't occur in natural living things. Does anyone remember reading about it?
The amount of amino acids?
Well, yeah, approximate number.
Oh, right here it is. They got 11 out of the 20 amino acids that you would observe. And moving on to this.
So when I was young and first heard about this experiment, I would have probably read about it in either the late 60s or early 70s. The results were that, well, they'd made over half, let's say, and in a short amount of time, and in a limited set of conditions. This, circulating glass vessel thing there doesn't have the full range of pressures and temperatures that the Earth has, as well as other chemistry, local chemistry types. But after Miller's death, he died somewhere, was it, I think they said in, maybe it was the Wikipedia page they mentioned, after his death, some of his vials were examined and with more sensitive techniques to probe that have developed in the intervening 50 years or so. And all of the amino acids found in modern living creatures were in his samples. All of them.
Yes.
He had made them all.
2007.
So that's when he died. And so the analysis was done after that.
So I say pretty recently, but I guess it was 11 years ago. Yeah.
And how should we say? This was the first attempt to do something like this, and in a sense, it was wildly successful.
Right. With limited understanding too, I would say. I mean, like comparatively to now. I mean, 60 years, 70 years. I mean, our understanding of it is exponentially grown.
So I think there's a funny thing to point out here, and that is that I know Urey, and I assume Miller, they weren't chemists, they were physicists. And so you got to wonder if some chemists, it was a little surprising that some of the chemists didn't jump on this first. But there have been other people who've done other experiments where they've added other elementary ingredients and done some interesting things. So during our discussion of the Drake equation, one of the things we talked about is that the habitable zone, and the initial idea about a habitable zone would be an orbit at a radius from a star where you'd have liquid surface water. But as you pointed out, there can be moons around gas giants well out of the habitable zone that because of their presence around a gas giant and orbital mechanisms to create heating, they can be habitable as well.
Absolutely.
And when and in the intervening years since the Miller-Urey experiment, we've sent probes that have looked at the gas giants, and on those giants, our probes see lightning happening. And in fact, they we see colored bands in the clouds on Jupiter and on Saturn. Those are complex chemicals that have been built there in those gas giants. There's, without doubt, we can say there's more organic molecules in Jupiter than there is on Earth. Because Jupiter's vastly bigger, and those bands that we see are, there's a word called, I think it's tholins or something like that. It is a class of organic molecules that are commonly made given the kind of average constituents of the gases of our solar system that have condensed into the gas giants.
Right. Yeah, and I found what you were talking about there, where they've made nucleotides, like adenine, and that's from adding hydrogen cyanide and ammonia in a water solution, sort of same experiment. So making nucleotides, I think that caveats into the RNA. So if you can make nucleotides...
What does the R in RNA stand for?
Ribonucleic. So
well, the ribo is ribose, and it's a sugar.
Right.
And some of the experiments have made ribose as well. So non-organic processes have made many of these pieces in glass vessels in the lab so far.
I think in the last 5 years at least, they've actually found natural ways to produce all the components you need for RNA.
For RNA.
Yeah, they tried other experiments with ultraviolet, and if you get the recipe just right, which happens in nature just by in random places.
Because nature has a huge space to work with, there'll be some nooks and crannies that may fall into the right space. So I've noticed that the time here, we're past the halfway point, and we should probably jump into the mid-program break. So somewhere here in our notes, it's the second to the last piece of paper. Now, I'll grab the first part. In case you're just tuning in, this is Freethought Forum, a program by the Atheist Society of Knoxville and the Rationalists of East Tennessee. Freethought Forum is funded jointly by them and by individual contributions.
We have moved. This is our new regular time, every Wednesday from 6:30 to 7:30 p.m. Eastern on Knoxville Community Access Channel 612, 99, or 193, depending on your local cable network. Tell your out-of-town friends to see us streaming online at ctvknox.org.
Yeah, and today's show is live, and you can call the number on a screen and speak with us. And while we take a short break, please watch our informative videos about our sponsors.
If you live in or around the Knoxville area and are questioning your religious beliefs or simply believe in one less God than everyone else, well, you're not alone. The Atheist Society of Knoxville is a fun and friendly group of people just like you that meets twice a week at a bar or restaurant. We meet every Tuesday night following the show. You'll find our group either inside or on the patio. Look for Richard Dawkins' silver-jacketed book, The God Delusion, standing upright on the table. But if you plan to preach, proselytize, provoke, or punch, please don't. We all question what we believe at one point in our lives. If this is the time for you, come join us for food, drink, conversation, and fun. Do you find stories of talking snakes laughable? Do you prefer the scientific method over supernatural beliefs? Are you concerned about religious leaders and organizations imposing their values and rules on your body, your family, and the rest of our society? Well, take comfort in the fact that you're not alone. The Rationalists of East Tennessee meets for fellowship and provides a forum for people who support skeptical thinking and rational discussion of these and other issues. To find out more information or to find out about our next meeting, visit us on the web at www.rationalist.org.
The Atheist Society of Knoxville, or ASK, meets one or more times a week. We have evening meetups for fun, food, drink, and conversation. Find us online at knoxvilleatheist.org. The purpose of the Atheist Society of Knoxville is to supply a venue for community camaraderie and outreach to atheists, agnostic, freethinkers, and other like-minded persons in the East Tennessee area. Next Tuesday, the meeting is at 5:30 at the Black Horse Pub and Brewery, 4429 Kingston Pike in the Western Plaza Shopping Center. when people come to the Atheist Society of Knoxville, we often have conversations about, we share our loss of faith stories. If we've been through something like that, we compare and contrast them. Sometimes we talk about the online conversations we've had with believers and the arguments we use for why we think that there's no reason to believe in any gods or gods. These are a lot of fun. So do you have some... Yeah, I've taken the thing that was fully scripted.
Oh, maybe not.
The Rationalists of East Tennessee, do you want to try and wing it?
What? They meet on the first Sunday in June?
We have meetings on the first and third Sunday mornings at the Pellissippi Technical Community College. It's the Goins Cafeteria Annex. And we sometimes show a DVD, or we'll have a discussion topic, and that way we practice the philosophy. And philosophy is what? You've had a philosophy class recently?
I did, but it's I regret to inform, being in the area that we find ourselves, it may have been heavily laced with theological beliefs.
So the etymology of philosophy is philos, which is to love, and soph, which is knowledge. So philosophy, or philosophers, are lovers of knowledge, and that turns into the kind of question of, well, actually, how do we know what's true? And a good philosophical discussion will often say, how do we know that that's true? What is the reasoning behind that valid? And how do you examine reason or methods of reasoning you put into the same method, or you apply it to examples, and you look to see whether it contradicts nature.
Right.
So that's how you test your methods of reasoning. The Rationalists of East Tennessee also has the Skeptics Book Club. This is the second Sunday of the month, and this is an afternoon event. It's from 2 to 4 p.m. at the Books A Million at 8513 Kingston Pike. This is not far from the Walker Springs exit. If you go to our website, rationalist.org, you can find out what the book is for June. As we can see, April's book was about viruses, and how it was called Planet of Viruses because there's a lot of them out there. In fact, we think sometimes of ourselves as the dominant form of life on the planet. We are negligible compared to the other forms of life.
Right.
Alrighty, well, let's get back to our program, our topic. We've got just about 15 minutes left. Viewers, if you want to call in and ask us about things related to abiogenesis or the question that we got on the screen there, we'd like to hear your comments or thoughts on that question as well. All right, what did you want to talk to, make sure viewers hear about?
So we had just talked about how nucleotides, the things that can make up RNA and your DNA, are being produced in nature. So I want to kind of touch on the other things as well. So like when you have these processes happening, it usually takes place within some sort of system, and not necessarily a closed system, but a more controlled system. And for our modern cells, what we have is what we call a phospholipid bilayer, and that's essentially just these lipids that are hydrophobic.
Lipid's a word not all of our viewers know.
Right. Okay. So.
They're molecules, right?
Right.
They kind of fit
they're
together.
Molecules. They're polar.
They're oily molecules.
Right. So they're polar. They want to bind together if they're in water because the tails are hydrophobic, so they don't want to be in the water. So they're going to kind of lump together. So these lipids naturally accumulate, and
so there's a material children play with that form a layer like this.
Oh, bubbles. We're talking about.
Soap is that.
Right.
Soap does the magic that it does because part of it can dissolve in water, it's polar, and the other part is non-polar. You make soap by taking an oil and treating it with lye. So soap bubbles are at least kind of like a lipid. I don't know that it's a bilayer. I would bet that it actually is. It may actually be thicker than that. But so everyone who's played with soap bubbles have played with something like that. We're getting another call here. Hello, caller. You've reached Freethought Forum TV. Can we get a name or a nickname, please?
Caller would be just fine.
All righty, caller. Can you give us your comment or question, please, and speak up as best you can?
Yeah, you just invited people to call in regarding abiogenesis or your topic for today. And I was calling in about your topic for today. And I was going to ask a question about that. And do aliens need Jesus? And I've been listening to your show for a little bit, and I haven't heard that question touched on any.
So last week's show, we talked about the Drake equation and how there's lots of planets out there. There's 300 billion stars. There's probably more planets than there are stars. The conclusion is probably got to be that life is common out there. Intelligent life, there's a lot less to know about that. But if there were intelligent life out there, caller, do you think those intelligent aliens would need Jesus?
Oh, you're wanting to know what we think, what the viewers think.
Yeah.
Oh, well, definitely no.
What's your reasoning?
Well, because according to the Bible, Jesus came to be the sacrificial lamb to remove the taint of sin that was created by original sin. And therefore, any aliens would not have the taint of original sin
Okay,
that
and
would
that's
have been
is
created
that
on earth, because they would not be, ancestors of Adam and Eve.
so? Let's make a case for and a case against. Who wants to go first?
Do you think that aliens do need Jesus?
Well, I guess it would be conditional.
I think that one would be the hard one to argue. Perhaps someone else would be better equipped for that. But
I'll
as
take
far-
that part then.
Okay, devil's advocate, as it were. So with the argument of if they need Jesus, so we were talking about intelligent life, and this show has been more about life arising in the first place. But say you do get to the point of intelligence, and you exist on a planet that's entirely separate of this sort of ideology, and say it were real, say it were true, and God had made these aliens as well as he had made the people on Earth, and he didn't give them this sort of guidebook that people seem to profess that he's given people here, nor has he given them sort of this sacrificial, as you mentioned, a sacrificial person to remove something that happened. Well, of course they wouldn't even know the existence of it. I mean, it would seem almost like a universe in which a God didn't exist, which I find kind of almost humorous, that they would be in that predicament even in a universe where a God did exist.
Well, the world didn't need Jesus before Jesus' time either. They would just sacrifice lambs and whatever in order to keep God from destroying them. And then when they died, they would not go to eternal damnation. So the definitive answer is no, aliens don't need Jesus.
So, caller, that means you think that no one went to hell before Jesus came. Is that
Well, according
is that
to
true?
the Bible,
The Bible doesn't say no one went to hell before Jesus came. The Bible simply doesn't mention hell before Jesus came. Right?
I think the accepted idea is there was no dead body that went to heaven or hell prior to Jesus, as far as the Jewish,
Christian Judeo.
The Hebrew Bible.
No, I'm talking about the Jewish tradition. There was no afterlife.
They called it Hades, I believe.
That's Greek.
That's Greek.
Yeah.
Well,
So in the Hebrew Bible, you'll see this word Sheol or Sheol.
Yeah,
That's-
Sheol happened to be the place outside of an area where you would dispose of that which has no use, a garbage dump. From
So,
what I
and-
understood.
And I think that sometimes it might be interpreted as the grave, because they would talk about, contemplating, standing, looking into the pit into which your dead body will go after, life goes away.
Yeah,
That
but all
Sheol
the
was
people,
the
all the
grave.
people in the Old Testament prior to Jesus, they were not concerned with saving their immortal souls like they were in the New Testament. Nobody was running around saying, "Let's sacrifice this lamb so we don't go to hell." No,
Right.
They were all saying, "Let's sacrifice, this animal because God won't get angry and come down and destroy us all." So God was in the Old Testament was only an animal, was only a creature that would torture and reward you during this life, not during the next one.
So you don't think that aliens need Jesus?
Well, if they did not have an original sin, they would not need Jesus. Jesus was our human. God created Jesus as being human. What was it? Man God, God man? What was it called?
Well, sometimes he uses phrase like,
Yeah, so he was
the
a
Son of
human.
Man.
He was the human representation of God. He was God incarnate in human form. So, if you're an alien and you needed any kind of savior, it would not be an incarnation of God in a human form, but incarnation of God in an insect form with feelers and stuff like that.
If
Pointy ears.
death entered the world because of man's sin, and if no aliens have sinned, are aliens immortal?
Are they immortal?
Yeah, if
I
death
don't
came into the
believe
world
that just
because of
because
man's
you were
sin.
sinless, you weren't immortal.
All right.
Because in the Garden of
here,
Eden,
take
Adam
my
and Eve did not eat of the tree of immortality, the tree of eternal life.
but also
They ate
it
of the tree
says
of knowledge.
it
So
also
Adam and
says
Eve were not immortal. So I don't know where that comes into the conversation.
but it only implied that death would happen to them if they ate of the tree of knowledge.
No.
For surely you shall die, implying
Yes.
that death
well,
came in.
That was a lie because they did not die.
Yeah,
But
I
see, also,
understand.
they had to be kicked out of the garden before they ate of the tree of everlasting life. So obviously, that was not correct, or at least there's some discussion there.
But there had been no death in the garden. The Bible doesn't talk. The Hebrew Bible doesn't talk about any death in the garden whatsoever.
Well, there hadn't been enough time, I imagine.
So what about the organisms living in this metaphorical garden?
Microbes have very short lifespans. I think that a lot of bacteria would have died.
Yeah. So the question is, do aliens need Jesus? Turns into the question of, do aliens die, and do they go to heaven and hell?
How would I know if aliens die or not?
And in fact, the Bible obviously didn't address that issue very well, and so it's not a very good handbook for how the universe works, is it?
No, I don't know. As to whether the Bible's a good handbook is not what I was calling to address. Subject is, do aliens need Jesus? I didn't know it would be that aliens die or not or anything like that. But if aliens needed any kind of
Savior.
savior, yes, it wouldn't be a human one, it would be an alien one. So I thought that was pretty simple. But apparently it's not as I thought it was.
Right, well, if
Aliens being immortal and stuff like that.
perhaps we're using a poor word here, a poor word choice. Alien being, something outside of our knowledge of species. And I want to think of it as more like another species. So say it's not quite, we come across something on another body, a solar body, and it's not quite as intelligent as we are. And we could almost equate it to animals that we find today. So, in that sense, when I think about that, I can't help but think that in the Christian Judeo sort of mindset, animals are just sort of these subservient.
Do animals need
automatons?
Jesus? And some of them are. Some Christians are going to say that animals don't go to heaven or hell, and others they don't want to disappoint their kids and say that Spot after he died is just dead meat, and so they will say, oh yeah, you'll see Spot again in heaven, and because in a sense, dogs and cats they're non-human. They're a kind of alien. They're just aliens that happen to exist, that we know exist, and share the planet with us. They're non-humans.
Okay.
Yeah. Caller, we'd like to finish up with you. Nathan, do you want to ask him the usual questions?
Oh, sure. How did you find us, caller?
I turned on my computer and you popped up on the screen.
Oh, okay. Did you understand our answers? Okay.
Yeah, I understood your answers.
All right. Have you watched before?
Oh yeah, I've watched before.
Great. Are you local or distant?
No, I'm outside of your area. I'm all the way down into Blount County.
Oh, okay. Well,
Long way away.
thanks for calling.
Okay.
Would you like to come out to Ask or RET events?
No.
Oh, okay. Well, if you do, there's websites.
Yeah, feel free
okay.
to call back.
.org.
All righty.
All right.
Thank you much.
Talk to you later.
Push the off button.
Thank
Bye-bye.
you. Bye.
All righty, we just got a couple minutes we can talk. We'll have to start wrapping up. So what important points do you want to make sure our viewers hear about? Take a minute. We'll make Nathan take a minute.
So I think we had touched on nucleotides. We had touched on how these containments are being created because of the hydrophobic lipids. We touched on that a bit. And then what I wanted to talk about was how early life wouldn't have been what people think of. You don't start off with a bacteria. You have to work up to that. And that revolves around this, what's called the RNA world hypothesis. And that's the idea that life started out as RNA, which is, like we've talked about before, this chain of nucleotides, almost like DNA, but it's a single strand instead of a double strand. And there's a nucleotide that's swapped out. So one of them is a little bit different, but it's still sort of the same framework that you'll see in cells today. So the idea is that RNA can be self-replicating because a free RNA can by itself create processes and ribosomes.
So RNA it both encodes information in the sequence as
Right.
well as it has enzymatic activities. It has all of the machinery necessary potentially to do reproduction.
Absolutely, and we've already demonstrated that the nucleotides necessary to create this are something that are found in nature.
That nature makes.
Right.
So in a world that had, let's say, a chemical soup built up like this Urey-Miller experiment, if you get an RNA enzymatic thing that develops that can replicate itself, it now can replicate and it has no competition. So the very first form of life doesn't have to be very good at it because it has no competition. But once it starts replicating, now selection can happen, and some are going to be better than others. But we have only half a minute left, so we have to do the wrap-up really fast. You can give us feedback at Freethought Forum at yahoo.com or visit our Facebook, Freethought Forum at Knoxville.
Yeah, or you and your friends can see this show on Wednesday evenings from 6:30 to 7:30 p.m. Eastern Time on this Knoxville station and on ktvknox.org.
And none of those who identify with no religion are the fastest growing religious group in America. And right here in East Tennessee, the Atheist Society of Knoxville and the Rationalists of East Tennessee are places you can find fellowship and fun. And you're not alone.
Not alone.